with respect to the origin O, A and B have the given position vectors, and we have the vector equation of the line. Part A, we need to find the acute angle between the direction of AB and L. We need to find vector AB first. Vector AB is given by vector OB minus vector OA. Vector OB is 3, 1, negative 2. Vector OA is 1, 2, and 1. So this gives us 2, negative 1, and negative 3. To find the angle between the direction of vector AB and the line, we need to find the direction vector of the line. For the line here, we have lambda, so the direction vector of the line is given by 1, negative 2, and 1. So this gives us the direction vector of the line. And to find the angle between them, we find the angle between vector AB and vector M. And we can use the definition of the dot product. So the dot product of vector AB and vector M, that is given by the magnitude of vector AB, the magnitude of vector M, cosine theta. Theta is the angle between vector AB and the line. Vector AB is 2 minus 1 minus 3. We dot this with vector M, which is 1, negative 2, and 1. The magnitude of vector AB, so we have the positive square root of the sum of squares of 2, negative 1, and negative 3. The magnitude of vector M, we have the square root of the sum of squares of 1, negative 2, and 1 multiplied by cosine theta. So to find the dot product, we multiply the I components, that is 2, multiply the J components, that is 2, the K components is minus 3. And this will give us the square root of 9, 1, and 4. So that is 9, 1 is 10, 10. After that, we have square root of 14. And 4, 5, and 6 here. We have cosine theta. So we have all that. And that will give us 1 here equals square root of 14, square root of 6 cosine theta. Or we say that cosine theta is 1 over square root of 14, square root of 6. Then to find theta, we find the inverse cosine of 1 over square root of 14, square root of 6. This has a value of 83.7 degrees. Part B, we need to find the position vector of the points P on the line, such that AP is BP. So the length of AP is the same as the length of BP. If we look at the equation of the line here, we can just find vector OP. So from the line, vector OP is given by 2 plus lambda. That is the position vector of any point on the line. And then we have 3 minus 2 lambda and 1 plus lambda. So we have vector OP, and then we need to find vector AP and vector BP. So vector AP is vector OP minus vector OA. We have 2 plus lambda, 3 minus 2 lambda, and 1 plus lambda. So we subtract vector OA. Vector OA is 1, 2, and 1. And vector AP now is 1 plus lambda, 3 minus 2, then we have 1 minus 2 lambda. And 1 minus 1, that will give us lambda. That is vector AP. We need to find vector BP as well. Vector BP is vector OP minus vector OB. We have 2 plus lambda, 3 minus 2 lambda, 1 plus lambda, minus vector vector OB. Vector OB is given by 3, 1, negative 2. So 2 minus 3, then that will give us lambda minus 1. 3 minus 1, we have 2 minus 2 lambda, and 1 plus 2, that will give us 3 plus lambda. AP is BP. If AP is BP, then the magnitude of vector AP must be the same as the magnitude of vector BP. The magnitude of vector AP is the square root of the sum of squares of the components of vector AP. And we have 1 plus lambda squared plus 1 minus 2 lambda squared plus lambda squared. And this is the square root of vector BP. So we have lambda minus 1 squared plus 2 minus 2 lambda squared. And then you have 3 plus lambda squared. We see a square root on the left and on the right. So we can actually square both sides to eliminate the square root. Then we expand whatever under the square root. That will give us 1 plus 2 lambda plus lambda squared plus 1 minus 4 lambda plus 4 lambda squared plus lambda squared. Then we do the same for the right. So we have lambda squared minus 2 lambda plus 1. Lambda squared minus 2 lambda plus 1 plus 4 minus 8 lambda plus 4 lambda squared plus 9 plus 6 lambda plus lambda squared. Let's look at this. We have a lambda squared and a lambda squared. So we can cancel that. So the 4 lambda squared and this lambda squared can all be cancelled. Then we have negative 2 lambda plus 2 on the left. And on the right, we have 6 minus 8. So we have negative 10 plus 6. So we have minus 4 lambda, 1, 4, and 9 plus 14. We rearrange this so that we have negative 2 lambda plus 4 lambda on the left. On the right, we have 14 minus 2. Then this will give us 2 lambda equals 12, and lambda is 6. So OP is just any point on the line. And it satisfies the equation that AP equals BP when lambda is 6. So to find the position vector of point P, vector OP is this part here when lambda is 6. So we have 2 plus 6, and then you have 3 minus 12 and 1 plus 6. And this will give us 8, negative 9, and 7. That will give us the position vector of point P.